Okay, so in case you want to replicate the Monte Carlo simulation from the previous video, let me show you what you need to do in Excel. So in a step 1, create a column that you call Obs for observation and fill it from 1 to 10,000. So create a series from 1 to 10,000, which occupies the array from A2 to A10,001. Then we create a second column next to it and call it xi, which will hold the random variable that we generate. That is what we do in step 3. We go to data, data analysis, random number generation, and then we enter number of variables 1, number of random numbers 10,000, distribution normal, the mean is equal to 0, standard deviation equal to 0, and then we can select the random seed. A random seed assures that whatever number I enter there, that will allow you to replicate the exact same sequence of data that I will generate. So I choose the random seed 42, but you can choose any other number. In theory, so if I chose, for example, 1, 2, 3, and then you enter in the random 1, 2, 3, you will get exactly the same numbers that I generate if I have also the random seed set to 1, 2, 3. But I set the random seed to 42 because 42 is a very popular seed among coders. Why? Well, because 42 is the answer to the ultimate question of life, the universe, and everything in Douglas Adams' The Hitchhiker's Guide to the Galaxy. So I will enter 42. If you enter 42, you will replicate the exact same numbers that I will generate. And step 4, the output range is then from B2 to B10,002. But let's first take a look at the little video, why 42.
Many millions of years ago, a race of hyper-intelligent pan-dimensional beings got so fed up with the constant bickering about the meaning of life that they commissioned 2 of their brightest and best to design and build a stupendous supercomputer to calculate the answer to life, the universe, and everything.
Oh, equal. We want you to tell us the answer.
And the answer to what?
The answer to life, the universe, everything. We really like an answer. Something simple.
I'll have to think about that. Return to this place in exactly 7.5 million years.
And they finished, they go back. 7.5 million years later. That's right. They do.
Equal. Do you have
An answer for you? Yes, but you're not going to like it.
Definitely, we must know it.
All right. The answer to the ultimate question of life, the universe, and everything is 42. Yes, I thought you never quite found it. It is 42. It would be simpler, of course, to know what the actual question was.
But it was the question. The ultimate question.
That's not a question.
Alright, so now we know why we like to use a seed of 42, but when you go to random generation, number generation, again, this is what you enter, number of variables 1, number of random numbers 10,000, distribution normal, mean 0, standard deviation 1, random seed 42, and here we have the output range. Then in the final step, once we generated the random variable, we square the random variable and multiply it by 10. So this will make sure that the resulting random variable is not normally distributed, but will be heavily skewed to the right. And then after we calculated those new values in column C, we copy and paste them back over column B2 to B10002. And finally we can create a histogram for the data with 10 bins. In order to do so, we probably use the command in Excel COUNTIFs. So we also will repeat again how to do a histogram. Okay, so now let me try to replicate that in Excel. So let me open Excel, and in the first step we create the column observation, and now we have to create a series from 1 to 10,000. So we can go to data, data analysis, and then we see here random number generation, number of variables. I forgot that's the next step. I have to start first creating a series. So we go to home, and then here fill, series, step value 1, and we end at 10,000. Okay, that is the first step. So now we have a column from 1 to 10,000. Now in the second step we create the random variable. So now we go to data, data analysis, random number generation. So we want one variable but 10,000 numbers. So 10, 1, 2, 3, 10,000. Distribution normal, okay, mean 0, standard deviation 1, so that creates a standard normal. Then random seed, we set 42, and the output range is right next to the observations. So we can click into the cell that says output range, and now I just go to the end of the first column, and I can highlight the array B2 to B10001. I'll just say OK. So now we created 10,000 random observations, but they are normally distributed. So if I highlight that column and I go to Insert, Recommended Charts, and I look at the histogram, you can see that it's nicely distributed, normally distributed. But we don't want the normal distribution. So that's why what we do is we quickly create next to the column B a new column in which we square the values from column B, and then we multiply it times 10. So now the first value that was transformed is 65.17. You should see the exact same number if you have selected the random seed. Now I copy down that formula. And so now I have a new column with the transformed normal variable. We squared it. In technical terms, that will become a chi-squared distribution. And I paste special values over the values in column B. So I just replace the values in column B and make sure that you only paste the values. And then we can delete what's in column C. So you should see the same numbers that I see. Maybe we can remove some of the decimals. So now we can see that this new variable is clearly not normally distributed. So let's highlight the column with the new data, and let's go to Insert, Recommended Chart. And you can see that the data is heavily skewed to the right. So we have a population which is not normally distributed. Okay, so but let's calculate the mean and the standard deviation for our non-normally distributed random variable. So the mean is equal to, enter the formula, average, highlight the cells from B2 to B10,001, and close parentheses. So now we have a mean of 9.83, but let's just get rid of all those decimals, so it's basically 10. Next, let's calculate the standard deviation, SD, and let's use the formula STDEV, standard deviation dot S. Select the relevant array from B2 to B10,001. So that's 13.89, but let's remove some of the decimals and then we get 14. So now we have a population which is not normally distributed and that has a mean of roughly 10 and a standard deviation of 14. So now what we do next is we take 10,000 samples from that population. So that will be the first sample, and we want to take 100 observations randomly selected from that population. The way to do that is to tell Excel, Excel generate a random number between 1 and 10,000, and then if that number is, for example, 6, then we want Excel to pick up the second value next to the 6, because 6 is like the observation, but we are interested in the characteristic of that observation. So let's say the observations are individuals and the characteristic is something like the shoe size or the height. So the way to do that in Excel is to use the formula VLOOKUP, which stands for vertical lookup. And then we said, okay, what do you want to look up? Well, we want to look up a random number between 1 and 10,000. So the first part tells you that Excel will look up a random number between 1 and 10,000. Then we have to tell Excel where do you want to look it up, and we have to identify the array. Well, I want to look up that number in the first column in the array that contains all the numbers. So that would be the array from A2 to B10,001, and now we need to press F4 to fix that array so that it doesn't move as we copy the formula. Then Excel wants to know the column index number. Well, in that array, after Excel found the random number in the first column, we want the second number, or the value in the second column. And if Excel wouldn't find that number, we don't want Excel to look up a similar number, but then it's simply not there. So we need to conclude that formula with false. Okay, so now the first number is 4.4. In your case, this is probably a different number because there is no seed in that formula. So you probably get now different numbers. You should see the same numbers like 65.18, 50.65 in the random variable that we generated, but we didn't select the seed anywhere here for the rand between. So don't worry if you see a different number. Okay, so now we copy down that formula 100 times. Okay, so you can see I have now 100 rows. Highlight, and now I press Ctrl D, copy down. And now I created the first sample that contains 100 randomly selected observations. And now I replicate that 10,000 times. So first I copy everything from cell E1 to the right, and then I go again to fill series, and I have a step value of 1, and then I want to stop that at 1,000. And you see, whenever you click somewhere in Excel and you have a formula like VLOOKUP, the values change every time you click on something. It just generates a new random sample over and over again. Okay, so now I have in the row, in the first row, the 10,000 samples. What I do next is I highlight the 100 randomly selected observations for the first sample, and I will copy that just 1,000 times to the right. So what I do is I go to column ALP. So I go to the end of the first row where it says 1,000, and now I highlight everything to the first column. And now if I press Ctrl R, I copy everything 1,000 times to the right. Okay. So now I have created 1,000 samples where each sample consists of 100 randomly selected observations. So in the next step, I calculate for each of those 1,000 samples the mean. So, and again, you see whenever I click on the cell, everything is being recalculated, but that's fine. We should always get the same result. So now we calculate for the first sample the sample mean. So we click enter the formula average, and now we highlight everything from cell, in this case E2 to E101, that captures the 100 randomly selected observations from the first sample. Press enter. Okay, you see the mean is 10.1. So now we copy this formula again to the right. I go to the end of those 1,000 samples and I copy the formula to the right. So now I have calculated 1,000 sample means. So now I copy those 1,000 sample means and I paste them special transpose into a new sheet. So I click into cell B2 and then I right click. Then I click on paste special, transpose, and I only want now the values, because whenever you click on something, Excel has a tendency to recalculate everything from scratch. So now we have here the 1,000 sample means. Again, I enter now in cell A1 the name sample, and we have 1,000 samples. So let's numerate them by using the series fill. And here we have the sample mean, or means. Okay, so now the magic of the, maybe we reduce some of the decimals. Okay, so now the magic of the central limit theorem is that the distribution of those 1,000 sample means that is normally distributed. Okay, let's double check. Let's go to insert and then recommended charts. And then you see that we will get here a normally distributed variable. Okay, what I will do now is I will actually create that histogram myself. And what we need in order to create a histogram is we need to know the minimum observation. So let's find the minimum observation, min. And now we highlight all the sample means. So the minimum mean is 6.27. Now let's get the max. The maximum value is found by using the formula equals max. And now I highlight again all the 1000 sample means. And now we can see that the maximum value is 14.95. So now the range is equal to the max minus the min, and we get a range of 8.68. Okay, so now let's create a histogram, and let's have 10 bins. And the first bin includes the lowest value, which is 6.75. So I create here maybe min and max. So the min is equal to 6.27. But I want to create 10 bins. If you want to create 10 bins, we have to divide the range by 10 and add that always to the minimum of each bin. Sorry. So the maximum of the first bin is then 6.27 plus the range divided by 10. Okay, so let's remove some of the... Okay, so then the end of the previous bin marks the beginning of the next bin. So I just use now the equal sign and I link to the max of the previous bin. And then we add again to the second bin the range over 10. Okay, and now I should be able to copy down that formula. I don't know, you should stop at something wrong. Okay, so let's copy this. Why is it always? Oh, hold on. Okay. G3. I think I have to enter the formula one more time. This is equal to this plus equals. Oh, I think I forgot. You see, what's important is you need to make sure that E4 is anchored. You see, that's a... So now I was wondering, why does that formula not work? Well, it doesn't work because the cell E4, which contains the range, well, that needs to be fixed. Okay, so now I should be able to copy that down. Okay, so the maximum is 14.95. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bins. And what we can do is now we can label that, and we can just say, okay, that will be the label of our histogram. We just say concatenate or take this value 6.27, but that has all the decimals, so we don't want all those decimals, maybe only 2. So we just say equals round. We use the command round, and then we highlight the cell G2, which has the minimum of the first bin, and we just say the number of digits that I want is only 2. Then we use the and sign, which is above the 7, so we press Shift 7, and then we want to add a minus sign and put that in quotation marks, and then we press again and then we want the maximum of each bin, which is round. And then we go to cell H2, which includes the maximum of the first bin, but you only want 2 decimals. So now you see the label for the first bin reads 6.27 to 7.14. Okay, so now we can copy down that formula. And next we calculate the frequencies. Okay, in order to calculate the frequency, we need a formula, count ifs. So we say count ifs, open parentheses. So now we have 2 criteria. So we count it if our sample, so we have to first identify the criteria range. The criteria range are our 1,000 sample means. There we need to count. So the criteria range is from B2 to B1001. And then what is the criteria? So okay, so we say count if. So we said, okay, count it if it's in there. And the first criteria is count it if it's, in quotation mark, greater or equal. And then we have to use the and sign, I believe. So it needs to be equal or greater to the minimum of each bin. So now we are done with the first criteria. Then I can actually copy this formula, and what I do is I highlight. I can copy the first criteria range and criteria. But what I still need to do is, I must not do the same mistake as earlier, I need to put that range in F4. And now I can just copy it, Control C, and put it next to it. And now the only thing I need to change is the condition for the second if. And the second condition is it needs to be less than the value in the max cell, which is H. Right? Okay, and then remove the comma, and now it should give us a count. So there are like 18 observations between 16.7 and 7.14. And now we can just copy down that formula, and now we have our own frequency table. And the only thing you can see that the count is 999, and that is because in the last one I need to add less than or equal to 0. So now we have 1,000 observations. So now I can create a histogram, and that should be normally distributed. So let's take a look into how it looks like. Insert, recommended chart, and you can see that the histogram looks normal. And of course, whenever it's a histogram, you remember we have to make sure that there is no overlap, so we have to remove the gap width. And yeah, so now you can see that we have a normal distribution. Let's take a look at the statistics. So we said the mean of those 1,000 sample means should be roughly 10. So let's calculate the mean. So we take average. We Okay, so that's 9.77, and rounded that is 10. And if you go back to our population and we reveal some decimals, so you see it's 9.83, so that's pretty close. And the standard deviation is 13.89. So let's take a look at the standard deviation. So the standard deviation of our sample means is 1.3 something. So rounded it's 1.4 and rounded it is 10. So we can see that indeed the mean is equal to the population mean. So that is equal to the population mean, which is 10, and the standard deviation is equal to roughly the 14 divided by the square root of our sample size, 100, which is the 1.4. Okay, so this is how you can derive manually the central limit theorem, and what it states hopefully is now clear. And then I'll just stop here, and then in the next video we'll just talk a little bit more about why the central theorem matters.